Today we're going to be talking about self-sufficiency, specifically energy self-sufficiency, but we will talk on self-sufficiency generally in home design and how you can achieve that. So first of all, I'm Roger Borland, Borland Architecture, and this is our design fundamental number 5, self-sufficiency. So let's break down what the problem is first of all. So you've been having a lot of experience, no doubt, recently in regard to your energy bills going through the roof. This has happened because obviously the networks have become more expensive here as well as we transition away from the coal and gas fossil fuel industry here and bring in renewables. That has brought some issues with it in regard to the availability of those fuels to create energy. And also, obviously, the international market in regard to energy with wars around the world and some of the hotspots for energy production generally from a long-term perspective and just general markets around the world. All of these things have had an impact on the cost of energy coming into our homes. What's more is there's a lot of volatility in that supply. Like I mentioned, the transition now to renewables. There's a lot of talk about the need to bring in gas into that solution as a transition, which I believe is not needed and should be avoided. We should be trying to create as many power plants as possible on each individual house, as I believe is the right solution forward, and having independent self-sufficiency. And so that's what we're going to be talking about today, is having self-sufficiency within your own control your own house and your own needs. So there's a few things that we need to go through first of all. And the first one is the performance of your building in the first instance. If you're trying to become self-sufficient on an older building that is very leaky, it's very energy inefficient, you're going to struggle to get to a point where you can become self-sufficient. So when we're talking about self-sufficiency here, we're talking about a new build or at least a renovation project which has this as part of a overall strategy for energy efficiency in the building. So we're trying first of all to reduce the energy load required for the building. And if you break down energy use in a building, it comes first of all, heating and cooling is usually the number one. Then you've got hot water, then you've got cooking and cleaning, and then you've got the general use of lighting and power through the house. So if we take number one, heating and cooling, and we create a building that doesn't require heating and cooling or requires only a little bit of heating and cooling, we're taking that number one energy demand off the list. And that therefore reduces your overall energy requirement on the building. And so that's what we try to do by creating a highly sustainable building in the first place. And that's what all of our design fundamentals move towards creating. So obviously then with the energy needs of the building reduced in heating and cooling, we also need to understand that the energy load and the demand typically has risen in recent times with the addition of more electrical appliances in the home, move away from gas to induction cooking, hot water systems that are electric, also a lot more gadgets and things that we're plugging into the home, charging batteries and so on. The demand has actually increased overall. So we need to counter that by ensuring that we make an energy efficient building that uses less energy on the other hand, so that we can reduce the overall demand. So how do we do this? So the first thing is that we create an appropriate performance within the building itself. So like I mentioned, if we can create a energy efficient building that is first of all orientated appropriately. So energy is all around us. The sun provides the energy that we have needed for thousands of years typically, and we need to ensure that we capture that in the right possible way within our homes and use that free energy where possible. And that means that we need to orientate our buildings in Australia to face north, with the majority of our glazing on that side appropriately shaded, so that is blocking out the hot summer sun, so that we don't require cooling inside, but allowing the winter sun to actually enter deep into the building and heat up our building for free. And if we do that, then we don't need to have systems to provide that heat and cool that we would typically need to manage those temperature fluctuations and make our life comfortable. So orientation is the first one. Then we need to think about the building envelope itself and making sure that that envelope is as energy efficient as possible. It's as airtight as possible so that we don't get drafts which are allowing the energy to leave our building. It is fully insulated in all junctions so that we're not getting energy loss through the building structure and fabric itself. So it becomes a nice warm dinner for our environment and keeps us warm and cozy on the inside, and keeps our temperature controlled and stable at all times. The next part of it is ensuring that we put fixtures, fittings, and equipment in our home that is as energy efficient as possible. And so this comes down to, things like our fridge, freezers, our washing machines, our dishwashers, all these type of things that use energy and we use all the time. Ensuring that when we purchase those items that they have the best possible star ratings on them from an energy point of view, so that we're reducing the demand on the building overall and trying to limit the amount of use that we have. The next one is, and we're going back to orientation here again, is if we're going to be self-sufficient in regard to our energy, we need to ensure that we have a source to gather that energy. So we typically in Australia have lots of great sunshine for solar production of energy, and so we need to ensure that we have a roof orientated as close to north as possible, ideally in Melbourne with a pitch of around 22 degrees, so that it's angled perfectly to be optimized for solar farming and getting as much energy from the sun as possible through those panels and making them as efficient as possible. And the second part of that is then having a battery system that actually captures that energy and stores it for times when the sun isn't shining, so that we get a nice stable energy supply without needing to draw from the grid. Obviously, always thinking as well towards the future. We do that a lot in our design process, and thinking currently there are a lot of electric cars around, so you'll probably have an electric car in the future as well. So optimizing that roof solar so that it will allow for an electric car to be plugged in as well through and using the battery, and these systems all working together so that we've got the right mix of energy coming through, so that you've still got plenty to run your home at the end of that as well. And obviously being an all electric home now as well, as required by code. Here in Victoria, you're not allowed to have a gas connection, which is great because it's lowering the amount of fossil fuels being directly connected to your home. And again, that allows you to become self-sufficient by providing electricity on site. And, that will then heat your hot water as well, which is the second highest energy demand in your home as well. So if we can do that again in a very efficient way using solar, then that is a great option for you. So obviously we need appropriate size solar for your supply. So again, there are lots of experts out there that can help you assess this through the energy requirements of the building, and pairing that with a system with solar and battery, with your electric car and other systems that are plugged into it, and making sure they all work as one ecosystem so that you've got optimal production of your solar. And then obviously any that you have left over, you could, if you are connected to the grid, you could sell that back to the grid. Now, talking about the grid, this is an interesting thing, because if you are energy self-sufficient, it's actually relatively simple then to become net zero and be disconnected from the grid entirely. So that means that you can not have any reliance on those outside factors, and all those connections that you typically have to the mains on, the you could have the sewer, you got typically previously gas and electricity. All those connections cost money to actually on a monthly basis for you to pay for those connections, but also during construction to make those connections happen as well. So if you don't have to have that, you're making a saving, right, in the first instance. So, and then you're obviously not in the world of volatility on the prices moving forward as well. So it's an important aspect of it. So you can become off grid relatively easy. And obviously, with off grid, you've got to think of other things beyond just energy supply. You've got to think of water harvesting. You've got to think of your sewage system. You may think about having an edible garden so that you can be self-sufficient from a food perspective, or as much as possible as well. And, these are extra layers that are on top of self-sufficiency that go into the thinking in regard to this. But specifically, we're talking about energy here, but it does take in a much wider ecosystem of these other self-sufficient ideas that can fall under the same topic. So that's self-sufficiency, and it is possible, and it is something that we're doing all the time. And if you want to know more about this and you have any questions, just leave a comment below or get in touch directly, and we'll be happy to answer those questions for you. If you find this useful, please like and subscribe, share it with a friend who you think might find this content useful as well. And we'd love to be in contact. So anyway, we'll see you on the next video. Thank you for your attention. Thank you. Bye.